Okay, so we have covered the physical layer. Now we are going to talk about how you can then implement, all right, using your MKR and so on. So this slide is just to share with you on the software side for Arduino. We do have an Arduino RS485 library. Okay, so you have to install this library. Later on when you come for your lab session, you need to install this. And please be mindful, as I have tried my best to highlight the importance and the difference between RS485 versus Modbus. So in the lab, we will first start off with understanding what is RS485. How can you simply send data over? Right, I will not go into the details. For today's lab, you'll be making use of this MKR 485 module. Right, you need to add this module onto your MKR to support RS485 communication. There are many more built-in functions, just like serial, which I've shared with you. But for RS485, these are the functionalities that you can make use of. So in the lab itself, when we talk about RS485 pass-through, I want you to learn about how this RS485 really send data out. All right. When I say without data frame protocol, here we are not making use of Modbus protocol. Remember, what is RS485? It is the concept or the physical layer that we talked about earlier on. So in RS485, we are merely using the wires as a means of transmitting data, right? Whether your data comes with any specific format, RS485 doesn't care. You send a 1, it will pass a 1 over through the wires. You send a 0, it will just send a 0 over. And this is what the physical layer is all about. So in this particular code itself, all right, what I would like you to work on and to pay attention to is some of the settings. And these settings really determine how RS485 is configured. So for us, right, since we only connect one RS485 module to our MKR board, we will keep all the deep switch to be to be off, right? So these are the position that you'll be using. And some of these settings, so the deep switch refers to the jumper setting, right? So this is commented out for your understanding how some of these are being used. The key part to the pass-through, right? By now, I hope you are familiar with Arduino sketch already. So this is the header. We are using Arduino RS485 library. And in the setup, we have two serial communication being set up. One is serial.begin. The other is RS485.begin, right? So we are establishing two types of serial communication. And of course, to enable your RS485, we have the begin transmission and to receive information. And in the main loop, all right, it is just these 4 lines of code. If there's serial, if serial.available is true, then we'll do a read from the serial, and then we write the data out. If there are data available from RS485, then we do a serial write, and then we write using those data that we are receiving, right? So this part can be a bit confusing. Let me just draw to you. Okay, so I'm going to sketch. My sketch is not going to be very pretty, but I hope this will help you understand what's going on. Okay, so imagine this is your laptop, right? This is your laptop. How do you connect your laptop to MKR? Anyone? You can write in the group chat. Okay, very good. Thank you. Okay, USB, this is your USB cable. Then your MKR is connected to MKR485. The MKR485 is the blue module that you saw earlier on. Then it will communicate to our sensor. Okay. So in this example, we are using RS485 as a physical layer of connection, right? So RS485 is how we connect the MKR485 and the sensor together. So the question now is that what is the communication between MKR and MKR485? All right, so my question is, what is the communication over here? What is the communication? Anyone? No, not Modbus. Okay, because we stack MKR and MKR485 together, all right, what is that communication between them? All right, so KIV for now, because you'll be experiencing that in the lab. So let me just explain this part first. All right, let me explain this part. When serial dot available, what does that mean? All right, it means that when you type into serial monitor, when you type something, when you type XYZ onto your laptop serial monitor, it will then send to MKR, right? It will send to MKR, and that is why MKR can do a serial read, because this serial read come from your laptop or come from the USB cable to your MKR. So your MKR will receive XYZ. Then what happened? Your MKR, when it receives XYZ, it will use the RS485 to send out to the sensor. So it will send XYZ out. And this is what is represented by the blue circle. Okay, now let me try and explain the other part. Now, what happened is that the line 41, if RS485 is available, all right, so this line is here. The MKR485, when it receives data from the sensor, okay, just imagine 1, 2, 3. Sensor send 1, 2, 3 back to MKR485. If there are data coming in, RS485.read will read what has been sent over. Okay. And when we do a RS485 read and we got the 1, 2, 3, we will do a serial write. So in the past lectorium, you probably have seen serial.write or serial.print. Remember serial.print? I think you all should remember serial.print. Serial.print. Okay. But in this example, they use write, which I have mentioned before. Read and write does this. I mean, they perform the similar task. They send out to your serial monitor. Therefore, when you do a serial write, all right, the MKR, when MKR do a serial write or serial print, it will print to your serial monitor, okay, which is at the base of your Arduino IDE, right? And it will print to your serial monitor 1, 2, 3. Okay, so this pass-through is actually to let you be part of the communication protocol, right? Why do I say to have you be part of the system? Because you are the one in front of the laptop. You can type onto your serial monitor to send data from your laptop to your MKR sent to MKR485, and from MKR485 out to the sensor. And then when there's data coming back, your sensor will return. In this example here, 1, 2, 3, it will send through the RS485 wiring to our MKR board, and the MKR board do a serial print or serial write onto your serial monitor. So this is what is going on. Okay, so the one that I highlight, I mean, I put in question mark. So here, okay, we will discover during the lab session. Okay, so this is just to give you a quick overview of what this program is all about. All right, it is not a very complicated program or sketch. What is important that I want you to take note is how we do data handling. All right, how do we do a serial read? How do we do RS485 write, and so on, so that data can be moved around and to make sense. Okay, in fact, I have the answers here. So take note, all right, serial is to communicate with your PC serial monitor. And in this case, this USB is actually creating an emulated serial port, right? Emulated serial port. And your RS485 module, the MKR, is actually doing a serial 1 to communicate between MKR and MKR485. All right, so it's actually using the serial pin. Okay, so this part I know can be hard to relate. Therefore, when you come to the lectorial with the lab hands-on, you will probably be able to appreciate this pin 13 and 14. RS485 is the physical layer that refers to how we wire the hardware together. RS485 is just one of them. We have the EtherCAT, which is the Ethernet wiring. All right, those are different wiring connection. So for Modbus at the application layer, it supports two types of communication. All right, it supports through RS485, and we deem it as a RTU. Right, we deem it as RTU if it uses RS485, and of course in this case it's wired. But if we are using Modbus TCP, right, TCP transmission control protocol, this TCP refers to the use of Ethernet protocol. And in joining the internet, it can be wired, right? We have the Ethernet cable to wire to a network. We can also make use of Wi-Fi to join the network. All right. So in this case, for Modbus TCP, it's quite versatile. It can be wired. It can be also wireless. Okay. So do take note. So Modbus supports two types, RTU and TCP. Okay. Next, coming back to something that I often get confused with, because all the while, or at least in the previous lesson from Prof. Howard, you have learned about I2C SPI, we use the term master and slave. Suddenly, over here, we see a different terminology. We have server, we have client, right? So server client terminology is to describe, right? There is a device that serves and there's a client to be served. Okay, so these are the different terminology. But if some of you have already tried to remember master and slave, because master and slave seems to be a bit more easier to comprehend. What I've done here is to help you by relating which is which, right? So for client, as I mentioned to you, client, just like customer coming to the restaurant, they are waiting to be served, right? So they are the master because they pay for the food. And there's a saying, right? Customer is the boss, must. Therefore, when you see client, I hope that you can relate back to a master, because in this case, who decide, I mean, in a restaurant, who decide the food to be served? The client, right? The customer that goes to the restaurant will order the food. So in this case, when the client join a particular network, in this case, Modbus, the client will initiate the request. All right. So the client will ask data from the sensor. So sensor is passive. In this case, the server, just like our lab, later you will get to see that the temperature sensor module, the Modbus module, is actually considered as a Modbus server. Why is it serving? Because the sensor has data. The sensor is waiting for the master to initiate. And when the master asks for sensor data, it will then respond, send over the data to the master. Okay, so I will not elaborate further on this. For those who find it difficult to digest, I hope that in the lab session, you can see how things are being arranged or how they behave. At least with that, I hope that you will gain better understanding to this concept of server-client protocol. All right. So back to the two different mode of Modbus. RTU supports multi-point, right? Multi-point because it's daisy chain, and many devices can join that chain. And the multi-point refers to the multiple devices that you can have. When there are multiple devices, remember the term addressable. Therefore, in order to address each of them, just like in a class, we have different students, and there should be unique names. Otherwise, when students with common names will call out, they may get confused. Therefore, device ID is critical, and we have to make use of this in a Modbus environment as part of the data frame. We need to provide the address of the device. For TCP, it is not required because it's point-to-point. Why point-to-point? The point-to-point refers to directly addressing to the respective IP addresses. Any device that joins the internet will be provided with a unique IP address, and therefore, the IP address will be good enough to identify and communicate to the Modbus server. Okay, so in TCP case, device ID is not necessary. Okay, for those who need to know more or wanting to read more, these are some of the links you can refer to. Okay, touching on the sensor, I've been talking about the sensor for a couple of times already in this lecture. This is that module, the Modbus sensor module. The sensor module is XY-MD02. All right, this is the module that we are going to make use of. It supports two types of communication. One, it is for RS485. All right, the earlier RS485 pass-through Arduino sketch that I've run through with you can be used to communicate with this module. All right, so that is the pass-through. In this screen that you are seeing, we are going to communicate to XYMD02 using Modbus protocol. All right, we're going to make use of Modbus, and it is using RTU mode, RTU remote terminal unit. Since this is RTU wired, it is also using RS485 wiring. Right, the physical layer is RS485. In the example code, this is the example code. Right, I will not. I should go through because I have received some feedback that some of you find that the Arduino code is still difficult to digest. So let me run through not all the lines, some critical one. Line 26, all right, this is to include the library. So this part, please install Arduino Modbus. In the lab worksheet, I have described to you which Modbus library to search for to install. Next, we create two global variable. Since we are measuring continuous quantity or analog, here we are trying to store temperature and humidity. We decided to use float so that we can store decimal point value. Next, to set up, all right, here to set up serial.begin, I think this is straightforward. I don't want to discuss more. Line 33 is a bit unique. Line 33 is a while, not serial, right? This line is critical because if you're unsure about line 33, if you were to deploy this as a portable device, you'll realize that your MKR will not run. This is because of line 33. So what is line 33 doing is trying to check your serial port, whether or not the serial communication has been established. So if you have your MKR not connected to your laptop, then your MKR will start at line 33. All right, so be careful. This line is often neglected by students, not knowing what it is supposed to do. And when you leave it there for your project work, suddenly you realize that things are not working because your MKR gets stuck over here at line 33. Right, we can share more or we can discuss this more during lab session if there's further question on this. So moving down, it is then trying to communicate using a Modbus RTU client to establish the communication to this module. All right. If there's no response from your Modbus client, then it will print serial print line, fail to start Modbus. All right. So this part is to check whether you have connected your wiring properly, whether your slave is responding to the master. So if there's no device, it will hang here. All right. Line 39 will be a while true. So it will stuck here forever. Okay, if things are good, we will go into the void loop. So void loop, all right, we will first of all check. What are we checking? We are going to do a request. Remember, your MKR is the master over here. It is the client is trying to talk to the sensor module and request data. So this part, this is wrong. In the original code, this is wrong, and you need to modify, right? You need to modify, and you need to read the data sheet in order to know how to change this information. So there are 4 parameters. Later in the next slides, I will describe what each of them is supposed to refer to. So if you have this 4 parameter information wrongly input, or you key in the wrong information, then because the sensor don't know what you're asking for, you will get this error message saying that failed to read register. All right, so this is what is going on over here. If you receive data, all right, from your sensor module, then we can do a read. All right, we can read the data and store into here. Once we store this, we can print it out. All right, we can print out. So this is what goes on. And for the void loop, is running at every 5 seconds. All right, running at 5 seconds. So what is this Modbus RTU client.request from? It is here. All right, so we are using this particular syntax. Syntax talk about how you should phrase your command line. We are requesting from who? From a device with this ID, what type of register, what is the register address, and how many register are we looking at. All right, so the parameters descriptions are here. And how do we know what to be used? And this is the part that you need to read out the data sheet. Right, so later, if time permits, I'll run through our lab worksheets with you so that you know what you need to prepare beforehand. Otherwise, you'll be spending time reading data sheet during the lab session. Okay, so this is the part to establish the understanding on wiring RS485. So in this week lab, you will really have to wire up a sensor module with your MKR485. That part discuss the topic on RS485. Then when you write your code, in this particular case, you are using Modbus protocol. Okay, in Modbus protocol, we have been discussing quite a bit on address already, or the unique ID. Something that we have not talked about is actually the error check, right? So last week, you have learned from Prof. Howard, right? You should know by now what is parity bit check. This is part of the serial communication RS232, where it will do parity check as part of the feature to make sure that your message is not corrupted. Why do we want to have message check? As I have explained, we want to be sure that the device that receives the data will be able to tell whether the data is clean or the data has been corrupted. All right, corrupted by why? Corrupted by what? It could be by noise, it could be by interference, it could be additional device, all right, unintentionally putting in data that cause this corruption. So in Arduino Modbus, all right, we have the CRC, cyclic redundancy check, in the background. And this is something that happens at the back end that users don't really get to see because all these are being checked within the embedded system. So in terms of message integrity check, I have talked about the parity bit in serial communication, which you learned last week. There are some of these checksums that some of you may have encountered when you download installers and so on. Why is there a checksums? Checksums is a quick way for you to identify whether or not there has been an inclusion of text or information that shouldn't be there. For Modbus, we are looking at CRC. So a very quick run through on checksums. As the name itself suggests, we are checking the sums. The sums refer to addition, all right, addition. And I hope by now you are familiar with having to deal with byte, all right, and hexadecimal. What is hexa? Hexa representation, all right, which is unique, so that we can actually handle them within a space or characters. So when we deal with hexa, we can then use 1 byte to represent our symbol in ASCII code. Okay, in ASCII code, for example, when you type A or the text or the character A, B, and C, these are the alphabets that you can send through a transmission line. But A, B, and C, as you learned from Prof. Howard, we are sending data serially. And this serial data is made out of 0 and 1s, right? 0 and 1s. And in the ASCII code convention, they are represented by certain numbers, right? In this case, letter A is represented by the hexadecimal 41, all right? But for decimal numbers, which we are so used to, we call it 65, okay? In computation of communication, we often use hexadecimal, all right? This is because when we deal with bytes, hexadecimal is easier for us to manipulate. Therefore, coming back to checksum, if we have 3 characters, A, B, and C to be sent over, the checksum will be to sum up not the A, B, and C, but instead the hexadecimal value, all right? So in this case, if you do a checksum of A, B, and C, our answer for the checksum is actually C6, all right, C6. You can punch your calculator, so this part is rather straightforward, so I will not dwell too long over here. Okay, just to do a quick check that you understood what I have mentioned, let's do a multiple choice. We are doing 8-bit, right? 8-bit checksum, and we are sending the characters, in this case, numerical characters, 8, 9, 1, and 0, right? What should be the checksum answer? This is simply taking all this and add together, all right? If this is a 8-bit, if you have any spillover, any higher bits or byte, you will drop it off and leave the 8 bits behind as your answer, right? So the answer is B, all right, D2, right, D2. This is, useful as you work on calculating the checksum. The reason for this is because when you are developing Modbus devices, and in order to know what has gone wrong, is it the RS485? Is it a wiring problem? Or is it that the checksum is always getting error, therefore you don't get meaningful data? Those are the things you need to know the gist or the fundamentals of this calculation. So checksum is just one of the simplest means to have, but checksum has its own problem. Okay, for example, when I talk about installer package having checksums, if there is a malicious code to be embedded, the hackers can in fact do a checksum to make sure that whatever he's going to add onto the installer would bring about the same checksums. If that is the case, then whoever took up the manipulated installer may not know that there is malicious software being embedded inside. All right, so checksum, although it's straightforward, it has some of this issue. Okay, so therefore, coming back to Modbus, I think Modbus has a more complicated cyclic redundancy code, which is quite challenging to digest at first. For those who are keen, I would probably point you to some of this link, right? I promise I will not test you on how to compute CRC, but why am I talking about this with you? As I have mentioned, if you have issues with communicating over Modbus, you must be able to know how to pinpoint where is the problem. So knowing how to calculate, right, it is important so that you can do a verification, all right, as a back end to debug what is the cause of the error or what is the cause of not able to communicate. And therefore, in order to do the checksum, the CRC, I know that I'm not going into the detailed algorithm. So what I've done is to share with you that there are tools to help us calculate. Okay, so in this case, for example, when we have 2 characters, hexadecimal 0207, so this is the 2 bytes that we are trying to send. When we compute CRC, we can use this CRC calculator. Okay, so for the CRC calculator, I will do a demo in our lectorial, right? I will do a demo in our lectorial on how to use this CRC calculator as a means to compute the CRC 16 checksum. Okay, do take note for those who are adventurous who want to try this out first, because CRC 16 checksum, there are lots of variants, all right? So make sure you choose Modbus, as Modbus has specific specification. If you don't choose Modbus, you choose other protocol, it will result in a different CRC checksum. Okay, so this is the part that you need to take note. And if you look at our, this information that I extracted over here, they have described to you in our data frame, Modbus data frame. We have the address, we have the function code, you have your data count, followed by the number of data that you're sending through. Where is our CRC? Our CRC is at the back, just like our parity bit. All right, CRC is at the back, and this CRC is computed only when this group of data is presented to you. Okay, when you don't have data, you won't be able to see, or you can't calculate the CRC. So in our temperature sensor data sheet, right, they have provided some of the examples. So for example, if your MKR send this data out, right, the device ID being 01, if you are using a function code 04, your starting address, all right, and then because the address is 16 bits, right, you use 2 bytes to form, your CRC should be 60 and 08, right, 60 and 08. So this is provided for you to verify so that you can do debugging or to check where could be the error from. All right, so this part I will do more in our lectorial to show you how we can do it. This is more to provide you with the skill sets of doing checks if you ever were to work on Modbus during your IWSP or in your future career.